All right, lesson 4, solving logarithmic equations. So two main methods you can use to solve logarithmic equations. The first one is to try and get matching logarithms on both sides of the equal sign, then solve using equivalence. So what that means is, like, if you have a whole bunch of different logs on one side, okay, and that equals, a couple logs on the other side, if you can get them to the same stuff. So if it has the same base, okay, and it's down to one thing here and one thing here. If this 3 is equal to that 3, or whatever number is there, then you can make the green stuff equivalent, okay, and just solve from there. Kind of like we did with the exponent stuff, okay, using common bases. It's kind of a similar idea to that. So the other one is to group them all onto one side of the equation and convert to exponential form and solve. Note, you can only take the logarithm of a positive number, so check your solutions. Okay, you might have an extraneous root or something that will not work for you. So here's an example: log 3 of x plus log 3 of 12 is equal to log 3 of 8. So the left side appears to be the product rule. So what I'm going to do is multiply and get 12x is equal to log 3, 8. Okay, well, the 3's are the same, so the 12x must equal 8. So just like using common bases, you can then set these things equal to each other and solve, and x will eventually equal 2/3. Okay, you divide by 12 and then simplify, and you get 2/3. Here's another one. Note that these are all 4, so it should work out okay for us here. So the first part is the quotient rule. So we are going to divide. So x squared plus 5 divided by 6 is equal to log 4 of 5. Okay. I suppose the other step you could do is, if you don't want to get a weird fraction like that, if you add log 4 to 6 to each side, you'll end up with this. Now the right side is actually the product rule, so we can multiply those two things. So we're going to get, there should be a 4 there, we'll get log x squared plus 5 is equal to log 4 of 30. Okay, so then you can set x squared plus 5 equal to 30, and then if you subtract 5, you'll get x squared equals 25, and then take the square root of each side. Now, careful, if you take the square root of a number, remember there's two cases. So x is going to be plus or minus 5. Plus or minus 5. And in fact, I'll write those in two different. So x is 5, or x equals negative 5. Okay. Just a quick recap. Why is the square root of a number? You get two solutions. Well, if I square negative 5, I get 25. And if I square 5, I also get 25. So you can't discount the negative solution here. But it turns out that we need to check make sure that they both work. So if you substitute in 5 or negative 5 into the original expression, it turns out that they're both okay, because you will end up squaring 5. So we do have a couple of solutions here. All right, here comes another one. Log 3x plus 4 plus log 3x minus 6 is equal to log 3 of 9. All right, so the first part is the product. So we're actually going to multiply these two. And you end up with x plus 4, and 6 minus x is equal to just 9. All right, and if we expand here, this will eventually become x squared. What do we get? X squared plus 6x minus 4x plus 24, and that equals 9. And so if we simplify everything here, we're going to get x squared minus 2x minus 15 equals 0. Now, if we factor this again, we'll get x minus 5 and x plus 3. So we have two solutions, x equals 5 and x equals negative 3. Okay, and just put them back into the original equation, and they both will result in positive logarithms. So logarithmic equation can often be solved by changing to exponential form. We've done this quite a bit, okay? So I use the rule of 7, not rule of 7, it's not a rule of 7, it's just like a little reminder, okay? So 10 to the 6 equals x, and we can actually evaluate 10 6, so x is going to equal million. Okay, x squared equals 25. Well, x must equal plus or minus 5 if you take the root. However, if we look and x is equal to negative 5, we can't have this negative 5 here, okay? So if I write these out separately, this will not work, okay? It's an extraneous root. Okie dokie. What can we do here? So 9x equals 3 root 3. Okay, and let's change this all to common bases. So the left side here is going to become 3 squared, and then that becomes 3 with the exponent of 2x. And the right side here, this is 3 1, and this is 3 half. Now, when you are multiplying powers with the same base, you can add the exponents. So this becomes 3 and to the 3 over 2. So then we can go ahead and set those exponents equal to each other, and 2x is equal to 3 over 2. So x is going to eventually equal 3 fourths. Okie dokie, so I'm going to switch back to blue. X to the negative 3 over 2 is equal to 1 over 27. So this is a common base problem again. Well, yeah, I guess you could solve a common base. If we want to just get x by itself, you can raise it to the reciprocal. Okay, and since you're multiplying that, that becomes x1. And you can actually evaluate 1 over 27 to the exponent negative 2/3 on your calculator, and it will come out to 9. So on your calculator, you would do bracket 1 divided by 27, use that little exponent button, and then type in negative 2 divided by 3. All right, and it'll get you 9. Okay. Here come a couple more. All right, so the left side, it's the product law, so we're going to multiply. All right, and then using our little thing here, I'll get 8, exponent 1 is equal to x plus 1, x minus 1. That's a difference of squares. So 8 is equal to x squared minus 1. If you add 1 to each side, you get x squared equals 9. And then if you take the square root here, you will get x is equal to 3, or x is equal to negative 3. If we check this, however, negative 3, if you substitute that back in here, you'll get a negative log. And so that's no good. So that is a solution that will not work. Okay, 2 log base 4 of x. So let's first of all change this to, let's bring that 2 back up. So we get x squared, and that equals 1 plus log 4x plus 3. All right, so I want to combine these 2 logs somehow, and they're on either side of the equation. So if I subtract, I can at least get them on the same side. So let's rewrite this, and if you notice, this is now the quotient rule on the left side. Okay, we're subtracting logs, so what we can do is create one logarithm, and we're going to have x squared over x plus 3, and that's going to equal 1. So now we can go and do 4 with an exponent of 1 is equal to x squared over x plus 3. Okay. I suppose there'd be another way you could solve this. Maybe I'll show that after. But let's go with what we got. So multiply each side by x plus 3. And the left side becomes 4x plus 12, and the right side is x squared. It feels like we're just flip-flopping stuff all over the place here. But let's get it to one side here. So 0 equals x squared minus 4x minus 12. And if you factor that, you're going to get x minus 6 and x plus 2. So 2 solutions, x will equal 6 or x equals negative 2. Just check them back with the original. Negative 2. Negative 2 not work? Yeah, negative 2 will not work, because if you put it in here, no bueno. So one solution. I was just kind of thinking about this one as I was doing it, and I suppose you could think about 1, instead of flip-flopping so much, you could just change this to log 4 of 4, and then apply the product law. Okay, you'd multiply the 4 and the x plus 3. And I think that gets you to like this stage right away. Kind of skips out a bunch of stuff, but there are multiple ways to solve these types of questions. Okay, a log within a log, interesting. So the first thing here, we're going to take 2 cubed is log x 256. All right, and so then we get 8 is equal to log x of 256. And then we can actually apply it once more, where we get x8 is equal to 256. And this would be a common base question, I suppose. You could see what multiplies to get 256 8 times, and it turns out it's 2. The other way to solve this is to take each thing to the 1/8, and you'll get x equals 2. Just evaluate that on your calculator. Okie dokie. Last one. 22 equals 20 plus log x. All right, well, let's get the 20 out of there. So we get 2 is equal to 2 log x. Okay, and then why don't we bring that 2 up? And we'll get 2 is equal to log x squared. Now, if you recall, the base here is 10, right? So we can go 10 squared is equal to x squared. 10 squared equals to x squared. X must equal 10. And there's our solution. That's the end of this lesson.